Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Longest substring with at least k repeating characters. Given we don't link with the longest substrings which are frequent. Okay. Yeah, I mean, I think this feels like sliding window, and we'll go over it. Don't worry about it. I am the way that I usually do these videos is that I record my reaction live as I read these problems, and also just explain my thought process. And the reason why I think it is sliding windows, or two pointers or two finger algorithm, is try to think about an invariant that happens as you kind of look at the 2 pointers and you go from left to right or something like that, and you're trying to make sure something that's true keeps on being true in a maybe greedy kind of way, in a way that maybe it does require some practice, of course. Okay, and don't worry, we'll go over it step by step, and yeah. Okay, so let's kind of go over the examples real quick. A is 3 times because k is 3. It's still I'm okay. I think it's a little less than or equal to k, but that doesn't make sense because b is 3 times. Also, a is okay, and also b is not in here, so it should be 5, right? Huh. Okay, well, trying to give me a sec. Okay, I think maybe the title is different from the. I think the title. Alright, well, I guess this is like a meta problem in that the title is at least, but the problem statement is less than. So I think the problem statement is wrong. They should fix it if this is a daily problem or whatever. Like, has no one complained about it? Am I wrong? It is a little bit weird. Okay, but I think it still is going to be sliding window in some variation, but now I have to think about it a little bit differently. Give me a second. So okay, let's just assume that it has at least k repeating characters, right? Okay, so can I do it in, well, okay, so I would say if it was at most k repeating characters, then it was definitely sliding window. And now I'm thinking through my thought process about what happens when it is at least k repeating characters, and whether some variation of greedy or something like that works. And because, for example, you can't just like put in c in here because, well, c has only appeared once, right? And with k is equal to 3, well, this is good, but well, I guess my question here then is, in terms of thinking about it, is does it ever make sense to, well, one is we have to get through it. So like now my mind, my visualization, my thought process and stuff is about kind of trying to think about, okay, you have these characters, there's at most 26 characters, can we take advantage of that? And how do we, this k doesn't even make sense, but okay, with respect to this length, but so let's say we start with an A. What invariants can we think about? And that's the way that I think about it if it's a sliding window. And I think I think I have a couple of solutions in my head, but I'm just trying to figure out how to best do it, because I think there's some sort of, like, I'm thinking of just like segments and then having some way of merging them in a good, efficient way. Given that n is 10 to the 4, we do need something either linear or n log n. So it has to be, not that slow, for example, because if it's n squared, it's obviously too slow, and not the intended solution, even if it's sometimes fast in some language. But I think it's going to be sliding window. Yeah, because I'm still reading the thing and it's still well. Because I think once we add in an A, what happens, right? Well, we have to keep on adding A's. So in that case, in theory, we can process until A's are, we have at least 3 of them. And then the condition will be keep on going on all the things that we have to process until we have at least 2 of them in this case. Because for example, if we have 2 A's, then, well, you have to have a B. And then now we have to get the B's, right? But then the thing is that, the thing is that now, because we're trying to get the longest substring instead of the shortest substring. If this is the shortest substring, this would be simple, because then we just get the first instance. And then as we kind of add more characters, we see if we could remove it. And yeah, but okay, I think the way that I think about it, and I don't know if it's a great way of teaching, I think there's some divide and conquer way as well, in terms of just try to figure out what characters you can use because they repeat enough times. It's actually kind of a tricky problem to do, right? The other variation is much easier with respect to at most, in terms of the invariant. I think for me, the in terms of kind of what I was talking about with kind of like these pseudo segments, because I think the way that I would also maybe have it becomes like a little bit of it's still like a sweep line algorithm where, for example, I think this is the way, but I think it's a little bit tricky to implement. That's why it's a little bit hard, which is that, okay, now we draw a segment between A and also B, and then just do some kind of intersection between these segments. But I think it's going to be hard. But I think one thing that we can do is trying to figure out another way to think about it. And for me, is that, okay, English letters in the alphabet obviously has at most 26 different distinct answers, or there's 26 characters in the alphabet, and it's an implicit constraint, or I guess it's explicit here, but that means that alpha is equals to 26, and I think in the final answer you can do a brute force on how many unique characters are used up, and I think that will allow you to get the answer by taking the brute force. Because if, for example, in this case, if you only use one character, then the AA, and then the you cannot do it with only one character, because it just goes through. If you have 2 characters, then you could do A, B, 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 and that'll give you the right answer. And again, so there's 2 parts of this proof. One is the sliding window, which we can kind of prove pretty okay on how that works given a number of unique characters. But then the harder part is proving that this is brute force enough or greedy enough for it to work. I'm going to go over I'm going to explain the solution as I code it out. Let me know what you think, and slow it down if you need, or speed it up if you think it's too slow. But yeah, I think so. For let's just say unique in range of 1 to 27, 26 inclusively. Unique characters, say. Okay. And we have a best answer is just what I call, best. And then now we want to do a sliding window, assuming that the final answer will have at exactly. Do I need exactly? Yeah, let's just say exactly, because less than isn't, then you already did that work anyway. Exactly 27 characters, and we just go through the array, right? So then now for character in S, what happens, right? Now we just have to keep track of stuff. I call it bookkeeping, but yeah. So basically, current unique characters is equal to 0. We have a set of I was gonna say set of characters that we've seen, but we can actually use a default dictionary as well, just to keep the count, or the collections.counter. This is very specific to Python, but it's basically just a mapping between any key value and an int. So yeah. So then now, okay. So with a sliding window, we always have at least 2 events, which is knowing when to add a character and when to remove a character from the, add a character to the right pointer and removing a character from the left pointer. And from that, you have to figure out what your invariant is, meaning that for every loop, for every iteration, you have to make sure that that condition is true. And the condition that we have is that the number of unique characters, and I guess we don't need this, we just use count, is less than unique characters, right? So basically, yeah, let's have a left pointer and a right pointer. Let's start them at the beginning. Maybe that's slightly better. I know some people do it another way, but yeah, I mean, because sometimes you do for range for C and enumerate S. Maybe that's slightly better. I'm still trying to figure out a good clean pattern for coding for that. But yeah, so basically this moves the right pointer in a sliding window, and now what happens, right? Given C, we add add 1 to the count, and okay, and then now the 2 things that happens, right? If the length of count is greater than S, or greater than unique characters, that means that we have to remove characters until we get under that limit, right? So that means that we are now subtracting from the left. Count. Okay, so this is actually a while loop, I suppose. Count sub S sub left. We minus by 1. We increment left, and from the invariant in this loop, for example, is that left cannot be less than, or left cannot go over right, because then this would just be trivially false, right? So yeah, but of course we have to do one more things, which is if this is 0, we have to remove it. Right, and that's so that's the moving left pointer. We just move it one at a time. This is moving left, or the right pointer, sorry, and then we move the left pointer when this condition no longer holds, to keep the loop invariant true, which is the outer here. So the invariant here is that once we get to this stage in the code, we have less than or equal to unique characters, and then now we have to do one more thing where I wonder if it's too slow, which is that for each character we have to be more than or equal to k, right? And right now I'm going to do the naive thing of just checking all the elements is greater than k, but I am doing it with the hesitation that maybe is a little bit slow, but I am not sure, so we'll see. but hopefully it should be fast enough. Because and on the like it might be close on the math, and we could go over the math later. But yeah, because the length of count is at most unique characters, right? So it adds a factor to that as well. So yeah, so with all of so key value in count count.items for all of these, v is greater than or equal to k for all this stuff, right? So this is the different k. I use k for key value, and that's a little bit confusing. So let me actually switch this to upper k, so I don't get confused later on if I ever use it, because that's a common thing for me. But okay. So if this is all true, now we can do the best is equal to the max of the length that we have now, which is the right pointer and the left pointer, right? Let me think about if it's +1 or not. I think it's +1 because we have to include both the inclusively, right? I think this is right. And then that's pretty much it. I think, unless I'm missing something obvious, but let's give it a spin. Okay, so that looks good. Let's give it a quick submit. Maybe I should have done empty strings and stuff like that, but it looks good. Okay, cool. So I think the hardest part, this sliding window is okay once you make the assumption that this is true. And in a way, the reason why this works is that it is brute force on the number of unique characters, and because you know that the answer can at most have, or will always have, you know, X amount of unique characters, and we seek to look for the best solution for each of those, as a way to check, you know, so in a way it's very brute force, and because given that you're looking for X unique character, you know that this is true because of the sliding window, because as you slide, the invariant here, that when we check, well, here the invariant is that there's at most k unique characters, but the invariant here for checking is that each of those items have at least they appear k times, which we check. And I think we can actually do some bookkeeping to kind of to, like, if you really want, you could get this complexity down a little bit, but apparently it's not necessary. So what is the complexity of this, right? So this is going to be linear, or like we have linear, this loop does linear number of operations. This, even though this looks like a while loop, or it is a while loop, the left looks at each character once, and the right looks at each character once, so it actually averages out to be linear. The only tricky part is that this actually takes all of alpha time. So this is up to 26, and this is also a loop of 26. So it's going to be alpha squared times O of n. So where alpha is 26 in this case, so some people may just say O of n, but I prefer to keep it with the number of alphabet. In terms of space, we have this collections of counter, which is again O of alpha, because it can have at most have 26 characters in the count. So O of alpha for space, or O of 1 if you may read that somewhere, because people like leaving out alpha for some reason. But yeah, that's all I have. So the short answer is just we brute force on the number of characters in the unique in the final answer, and then we do a sliding window on each of those. I think this is a really hard. I might look for the solutions real quick and then see if we can go through them together, just for me to learn as well, because I think this should not be a hard problem, but I think I gave it a really hard solution that is tricky to prove. So let's kind of give it a look. Maybe I missed something. I think there's a divide and conquer one as well. Oh, there's the brute force. Well, okay. That's actually just brute force, but n squared is going to be too slow, right? If it's fast enough, then maybe in some languages fast enough, but oh, yeah, okay. Time limit exceeded. Divide and conquer. Okay. Yeah, I was gonna say that's the way that I would also maybe do it, because yeah, you could just divide it by the. But I thought that I had some reservation on the complexity, because I thought the worst case could be n squared. Oh, and that's what it mentions here as well. So yeah, does that not slide long enough? Okay. Yeah, I have the sliding window, but is that the way that I did it? Yeah, I guess this is the way that I did it. So I recommend reading through this again if you still have some issues. But that's like a really yeah, I don't think this is. I think I read somewhere that this is medium. Yeah, this. I don't think this is a medium problem. I think this is a hard problem, to be honest, because it requires you to think about a dimension that's a little bit tricky. I mean, maybe we've seen it before. Maybe it's a little bit better, but I don't think this is an easy solution or a medium problem. So I'll definitely take my time on this one. Anyway, that's all I have for today. Let me know what you think. Join me on Discord. Hit the like button. Hit the subscribe button. And I will see y'all tomorrow. Bye bye.